All right, guys. This is the beginning of the PowerPoint that I sent you on slope fields. It's going to centralize around this worksheet. I attached this in Google Classroom not too long ago, but it's going to center on this worksheet that looks like this, which is off of the CPM. I'm sorry, not the CPM, the AP website from College Board. But basically, we're talking about slope fields, and this is the worksheet that we will be going over why we do it. But here is the PowerPoint we're going to work on, and it's a quick run through. Basically, slope fields, we're looking at differential equations, which are the equations of dy over dx. That's really what we're looking at, any kind of equation that looks like that. And they do all these things right here. We're going to look at the derivative of the equation. We're going to use the derivative to find slopes. Okay, and basically the slopes are changing throughout, so we are actually plugging in x's and y values to find these slopes for a lot of these problems. And then we're just going to, you'll see as we go through, but we're just going to kind of make tick marks. At certain points, we're just going to make little mini slopes each time. So it's easier to show you than talk about it because I'm not that great at talking about it. So there's a quick link. These are the three things that you would probably need to be able to do for the AP test. We're going to do a couple examples on each of these sections. The first is I'm going to give you a graph of a slope, or I'm sorry, well, it's all over the place, but given the graph of a slope field, find the differential equation that matches it. Given the slope field, estimate the values of a solution. So I'm going to give you an initial condition, and you're going to estimate what the slopes look like for that initial condition. You'll see when you look at that. And the thing we're going to start with, we're actually kind of going in reverse order here, is we're going to sketch a slope field first to show you what it looks like. I'm going to give you an equation, a differential equation, and we're going to sketch that slope field. And again, this is a part of the PowerPoint where we do that. So here's the first thing that we're going to look at. I give you the original equation of dy over dx equals x squared. So I'm saying the slope is x squared. So let me set up a pen. I'll do red. And basically, we're going to essentially just look at all the little points on here, and we're going to make as many slopes as we can. Now, it's going to take me a really long time to do every single one of these points, so I'm just going to do like 6 or 7 just to give you an idea. And I'll show you what you'll eventually see what they look like completed. It's pretty nuts. But basically, you're just going to go and pick a point like right there, 0, 0. And you are going to write dy over dx. I'm not good at this. Equals, and you're going to rewrite the problem. So for 0, 0, we're simply going to write 0 for x squared, and then 0 for y. Well, there is no y in this, so all of the y values are going to be meaningless. I'll show you some problems where they actually mean something. But we're going to get 0 squared is 0. So there is going to be a horizontal slope like that of 0. And you can kind of look at that and say, okay, so for any one of these points, that was 0, 0. If I want to do 1, 0, right, that's right here. 1, 0 is right there. We're now going to put in 1 squared at 1, 0. So at 1, 0, we're going to get 1 squared, and that answer is obviously 1. So we make a slope of 1. So you can do, a lot of these are going to be kind of estimated. Hopefully mine isn't too bad, but we're going to kind of go like that. You're not going to draw it on the whole graph, just a little snippet of the graph, and you're going to make a slope. Then for 2, 0, we're going to be putting in 2. So for 2, 0, we're looking at 2 squared, which is 4. So for 2, 0, we get 4. So all you're going to do is make it steeper. So if you really want to be accurate and precise, you take a ruler, you go up 1, 2, 3, 4, you go over 1, and you take a ruler and you literally connect those to make a nice steep slope that fits that. I am not going to be doing that, but you can kind of see how it's steeper now. And 3, 0 will be 9, and by the time we get to 6, we're getting to 36. We're talking about really steep slopes. I can't really show you all that on here. I'll just do my best. You're going to make it a little steeper. 4 is going to be a little bit steeper than that. 5 is going to be pretty steep. 6 is probably going to be almost up in the air based on our graph. But the slopes, mine isn't great, but they're going to keep changing, get steeper. And then if we put in the negative, -1, 0 is going to be 1 when we square it. So we're looking at something like that. And then the same idea. Make it steeper, make it steeper. If I had more space, this would probably look better. I'm doing the best I can. You just have to kind of use your imagination and think that, man, he's doing steeper slopes every time. Okay, and then we're going to go through like as many points as we can and do that. So if I went to this point, 1, 1, it's the same thing. Putting in a 1 for x, 1 squared, the slope is 1. So what you're going to find here is that all these slopes at 2, 1, 1, 2 at 1, 3 are going to be identical. 1, -1, the y isn't changing anything. So these slopes at 1 will all be the same. Yikes. But you want to have those being exactly the same. And it's going to happen that whole way through this whole graph. So here all the slopes will be -1. Okay. And you hopefully get the idea what's going on here. And like I said, don't worry, it would just, oh, that was a good one. It would just take me way too long to do this whole thing because I'm really slow at it. Oh, and all the zeros here, we're putting in a 0 for an x and the y isn't doing anything, so it's always going to be like this. So we can kind of build the slope like this. A lot of people like to compare them to like ripples in a pond or something. Like you can see like everything's spreading out. But all these slopes that we have here are going to repeat themselves as you go vertically. All right, but that's what a slope field is. That's how you create one. We'll do a couple examples. Here's a nice easy one. dy over dx equals 2. That's pretty simple. Basically, there are no x's, there are no y's. The slope is always 2 no matter where you're at. So every single one on here, you're just going to make a slope of 2. So if I started right there, there'd be up 2 over 1. You just try to do your best to make that slope. Every point on this entire graph is going to look like that. Every slope, because the x's and the y's are not going to matter at all. So again, I'm not going to do the whole thing. Hopefully you're listening and this is making sense. Yeah, I'm missing a little bit, but every point will have a slope of 2. All right. And just imagine this whole thing being filled up with 2's. And again, a couple slides earlier, I kind of skimmed by it, but it's a slope plotter. If you go to this and check out this link, you can actually do these and kind of it'll give you a good visual of what they're supposed to look like. It's a pretty cool tool. As for your worksheet, here's your worksheet in action. So x plus 1, you can try that. I wanted to show you one of them where we have an x plus a y. So this has both of them. So what's going to happen is that when we do a point, for instance, a 1, 0, we're going to use the x and the y in our calculation. X is 1 and the y is 0. So slope at 1, 0 would be 1. So at 1, 0, we do our best to make a 1 slope. But then when we go over to 1, 1, which is right above it, now we're going to do a 1 plus a 1, and we're going to get 2. So up here at 1, 1, the slope is going to be a little bit steeper. Easiest way for me to do that is go down to left 1 and kind of visualize what that would look like. But bottom line, it just needs to be steeper than that. And if I go to 1, 3, well, that's going to be 1 plus 3, which is 4, which is steeper than the last one. So we're making continually steeper slopes. And if we go down to 1, -1, that's going to be 0. It's a flat slope of 0. And if we go to 1, -2, we're adding 1 plus -2. 1 plus -2 is -1. So we're going to repeat this up here. Okay, and then 0, 0 will be 0, flat. 0, -1 would be a slope of -1. So this one's a little different than the last one, because the last couple we had only an x or only a y. So you generally kept the same slopes in a vertical or horizontal line. Now they're going to be changing. You can't just copy the slopes. Here's 0, 1. That's going to be a slope of 1. 0, 2. It's a slope of 2, so a little bit steeper. All right, and we keep going through here. Here's 0, negative 2. That's going to be a slope of negative 2. So a little bit steeper than this one here. So there we go. I'm going to do one more row over here with the negatives. Negative 1, 0 would be negative 1. Right? Negative 1, negative 1. I'm sorry, negative 1, 1 would be adding up to be 0. And negative 1, 2 would be positive 1. So you might be noticing some patterns here. There are some. Negative 1, add those up, you get negative 2. So this is a steeper slope in the negative direction. And negative 1, negative 2 creates negative 3 when you add them together, so a slightly steeper slope. So what you might notice is right here, these diagonals, you are getting the same slope. Okay, that's not always going to happen, but notice these patterns. It can help you out a lot. It can save you time from doing these. But you're going to create this whole field, and you're going to make a field that looks like this. And we'll talk about what these fields mean and how to use them, but I'm just giving you the gist of how to create them yourselves. All right, so you can try some of those. They're pretty neat. And then the next section we will try will be given a slope field, select a differential equation that matches it. What's cool about this is all the ones we just did, you're going to start seeing what they actually look like. They look kind of like this as you go through them, so it's pretty funky. So I am going to stop this video right now, and then I will go ahead and make a video on this part of the presentation so we can kind of do one thing at a time. All right, I hope this helps. If there's any questions, just post them or contact me via email, and we'll try to clear that up. All right, so you should try this part of the worksheet if you haven't done it already. All right, good luck.